Okay, good morning, everyone. Today we're going to continue our discussion on multiple linear regression. We were using the wage data set, and we already did the full model. When I say full model, we included all the predictors as our independent variables. Okay, education, experience, tenure, etc. And the first result was that education and tenure and gender were all highly significant at 0.001. Experience was significant only at 10%. The rest were not significant. And we said, do we stop here? Not necessarily. Okay. There is a process called stepwise regression where we trim down the variables because it's possible that the variables are affecting each other, and maybe it's also possible that two variables are insignificant because they are highly correlated. So it's possible that when you remove one of them, one can become significant. So what we did was to determine which was the living variable. Okay. Aside from that class, before I continue discussing that, we also took a look at this. So this is our goodness of fit test. This is our combined test. Our overall goodness of fit test. And you have here the residual standard error, degrees of freedom, okay? So you can find here 2 degrees of freedom, 7 and 518. We know that, okay, how many observations do we have? Enroll, wage. We have 526 observations, okay? How many predictors are there? And call, wage. So we have 8 predictors, but one of them is the dependent variable. So we actually have 7 predictors. Now, when you have your F test, you have degree of freedom 1, okay? And you have your degree of freedom 2. What is your degree of freedom 1? Your degree of freedom 1 is your number of predictors. Number of predictors. So how many predictors do we have? Our predictors is n column of wage and -1, right? -1 because we don't include the dependent variable. So that's our degree of freedom 1. Okay. There, 7 class. 7. And what's our degree of freedom 2? Degree of freedom 2, alt minus, is your number of observations. That's your n. Okay, number of observations minus your k. K is the number of predictors, okay, which is your df1, okay, and then -1. Okay, so that's n minus k minus 1. So that's to accommodate for the intercept that's also predicted. You lose 1 degree of freedom because we're also predicting the intercept. So that's our degree of freedom 2. Number of observations, which is 526, right? Here. Minus number of predictors, -1. So this gives you, sorry, df2. That's 518. So that's where this is coming from, class. Okay. That's where this 7 and 518 is coming from. And it makes use of F statistics. Okay. So what's being tested here? What's being tested here is you have one null hypothesis. Okay. And that's your B1 is equal to beta 2 is equal to ... is equal to, how many predictors do we have? 7. Okay. And it's equal to 0. So it's a joint test of significance. Unlike here, class, we studied this, for example, this is beta 7 is equal to 0. it's your individual t-test. Individual class and ginagamit t-test. Alright? So this is your null hypothesis here. So that's the difference, class, between the hypothesis here in your individual t-test and here in your joint test. And the p-value is practically zero. So our conclusion is when the p is low, the null must go. We have to let go of this null. We reject the null hypothesis that beta 1 is equal to beta 2 is equal to that is equal to beta 7. There's strong statistical reason to believe that at least one of them is statistically significant, is a value other than zero. Okay, so that's what's happening here, class, in this test. Okay. So I hope, class, that whatever this result, class, we have the confidence we understand what this is. And one other thing, we actually discussed this 37.04, 36.19 last time. Did we? I'm sorry, I'm getting confused with the other section. Okay, let's just do that, class. Okay. That's the let's discuss, class, the this one. Okay, the multiple r squared and the adjusted r squared. There's a difference between the two. Okay, when you have multiple linear regression, what is preferred is the adjusted r squared. But let's compute first for the multiple r squared. How do we compute, class, for the multiple r squared? The formula is, okay, okay. The formula is, where's our SST here? Okay. The formula for the r squared is this one, SSR over SST. May I be clarified, class, if we discussed these formulas last time? Can you please confirm kindly? Chat, please, class. Okay, yes, thank you. So quick review na lang, no? Okay, so we need to identify three metrics: SST, SSR, and SSE. So let's start first with SSE. This is very simple. We're saying that it's the sum of the squares of your actual value y sub I minus your mean. So this is saying, class, sum of the squares total. Some books call it TSS, total sum of the squares. We're saying that we're not going to use any of the variables. Okay, we're not going to use our exogenous variables, our independent variables, in order to model our y sub I. We'll just use the y variable itself, the wage data set. We'll just get the average. Okay, so our prediction will be average. That will be our simple prediction. Okay, so you just get the average of y sub I. Okay, let's do that, mean of wage dollar. Sorry. Yeah, our data is wage dollar, hourly wage. Okay, hourly wage. What's the average of that? Control enter. Okay, 5.896. Okay, so no matter what the observations are, our predicted value is 5.896. It's very simple. It's very straightforward. However, it has a lot of weaknesses. So let's take a look at the errors. If we're going to use the mean, what will be the total errors, class? Okay, for example, what will be your wage? Okay, wage dollar, hourly wage, and just get the first one. What will be the first observation? Control Enter. Okay, it's 3.1. Okay, 3.1, and then our predicted value will be 5.896. So that's a total error of 2.79 class. Because we're not using the external variables. Let's just use the wage data itself, the hourly wage data. So for the first observation, that's a big error. We are overstating our prediction. So let's get the overall squared of the quote unquote errors when we're going to just use the average. So how do we do that? So let's create SST, okay, out minus is equal to, let's first get y sub I. So that's from the wage dollar, hourly wage. Hourly wage, okay? So this one class contains all your y sub i's. And then we subtract it by the, I'll just copy this class, mean. Control C, Control V, by the mean of the hourly wage. Okay, so we're subtracting here, and then we have to get the square. Squared. There you go, class. We squared it. So there will be 526 observations. Since there are 526 rows, there will be 526 y sub i's minus the mean. So there will be 526 values for that. And then we should sum that up. Okay, let's put this in sum, open parenthesis, and then close parenthesis. There you go. Okay, so this will just be one single value. Okay, so that's our, okay, I forgot to print 7160.414. That's our total sum of the squares. Okay, SST. Okay, so let's go to regression here. This time, what we're doing is, we said that, okay, from the base prediction, which is just the mean, okay, let's compare it now with our predicted value. Y hat, okay? Maybe we can increase this. Let's see what will happen. Oh, yeah. Okay, anyway. So let's do this class. That's you can see we're comparing the predicted value and the average. So where do we get the predicted value? Isn't it we created this model mod 1? Let's take a look at mod 1 class. This is our regression model mod 1. Here. So here you have your coefficients, 7 all in all, because we have 7 predictors. We also have here our residuals. Okay, the residuals, and then the predicted values are here. Okay, may question ba? Ay, okay. Thank you, Jerry Lane. All right, sige. Anyway, we're discussing, no? We're discussing. Okay, apologies din class, no? So, I'm sorry kasi nag-overlap na tayo sa ano sa FinLits. Although sa FinLits ano lang it's just a more generic discussion of linear regression. Dito talaga mas deep dive tayo. Okay, so I was saying class, in order for us to understand or to compute for the R squared, which is a measure of how much proportion of the variation of your dependent variable can be explained by our model. Here it says 37%, no? 37%. And here we have your adjusted R squared, which we're going to look into in a while. Okay, so we need to compute for the SST, sum of the squares of the total. And SST here, class, as we said a while ago, we already computed it. Okay, it's your actual value minus the average value. Okay, and then we square that and then get the sum. So we show that here, di ba? Ito yun. We have 7160.414. Okay, let me pause for a while, class. Is there any, did you get that, class? Maybe some of you have questions about that. Kindly chat, please, if you were able to get 7160.414. And did I give you already this, class, this LaTeX formula for SST? Feedback, please, class. Okay, yes. Thank you, John. Okay, so meron na nito, no? Okay. So again, feedback, please, class, if you were able to get 7160. Waiting for your feedback, class. If you have any questions, please feel free to raise your hand. O chat na lang. Okay, good. Thank you. So let's give our classmates a few more seconds, class. Sometimes I tend to go fast. So you need to call my attention and stop me. And again, we would like everybody to be able to follow along. Okay, great. Thank you. All right. Thank you, class, no? So ito yung SST natin, no? Ito yung total variation ng hourly wage data natin. Okay? Now, let's take a look at how our model was able to improve on the mean. Kasi ito yung initial model natin, di ba? Ito yung base model natin. Just get the average. Now, we're using several independent variables, okay? In order to model our hourly wage, di ba? So, i-compare natin, class, yung predicted value natin from our model 1. Okay, so let's write here SSR out minus, and it's equal to, once again, class, let's get the predicted value. And we said a while ago that the predicted value, we can get it from model 1. Okay, dollar, saan siya, class? Fitted values. Yan yung mga predicted values natin. No? Minus, once again, si mean na naman natin. Mean ni wage, dollar, hourly wage. There. So we're now getting the difference between the predicted value minus the average. But we have to square this, no? Kasi square natin, square. And then, once again, get the sum, summation. So I'll put sum here and put everything in parentheses. Sum, open parentheses, and then close parentheses. There. Sum of the squares of your regression. Let's run this. Oops, sorry, nakalimutan ko na naman. Print natin sa SSR. Okay. 2652. So this was the variation that was that was covered by our regression model. Okay, and lastly, class, SSE. We'll explain SSR in a while. SSE class will just be the sum of your actual minus your predicted value. So ito na yung residuals nating class. This is now the difference between your actual value and your predicted value. Kung ano yung hindi kayang na what the model was not able to explain. So you have sum of the squares of your errors or sum of the squares of your residuals, okay, alt minus. Then once again, we have the actual value is from wage dollar, okay, up, tab. That's your actual value, right? Minus your predicted value, again, from mod 1, dollar. Oops. Down fitted values. There you go. So difference sila. And then we square this. And then we get the sum. Sum, open parenthesis. There you go. And then let's print SSE. Okay, enter. Let's run this. 4508. Okay, 4508. Now notice that, okay, if we add SSR, a 7160.414. And that's exactly the same as your SST, 7160.414 guys. Okay, so we can really conclude that the total sum of the squares is equal to your regression sum of the squares and your residual sum of the squares. Okay, so now we can get the R squared. R squared is simply the proportion of your regression variance, this one, okay, that which we were able to improve on based compared to the mean, okay, divided by the total variation. The total variation is 7160.14, right? So if we get R squared, which is SSR over SST, we get this. Control enter. 3704. Okay, 3704, and that's this one. 37, rounding off lang, no? Kasi hindi naman exactly 3703 to. It's more than that. 3704, 3703. Okay? What's important here is that we can say that 37% of the variability of our dependent variable hourly wage can be explained by model 1. Model 1, where we use all the predictors. Okay, may I have your confirmation, please, class, if you were able to follow? Thank you, Chard. Okay, how about the others, please? Okay, good. Good. Okay, so let's just Control Alt I. So we can write here SST. Print natin, no? SST, SST, SSR, SSE, and then we have SSR over SST, SSE over SST. Okay. If we print all of this, okay. So this is your total variation, 7160.414. This is the variation that can be explained. Okay. This is the variation that cannot be explained, sum of the squares of your residuals. This is the proportion of the variation of your hourly wage variable that can be explained by our model, 37%. Therefore, around 63% cannot be explained. This is your unexplained variance. This is your explained variance. Okay, so I hope these figures make sense. Okay, now where do we get this class? Itong adjusted R squared. Now, every time you add variables to your model, let's say I add 10 more here. What happens is that your multiple R squared will, of course, increase, keep on increasing. Okay, however, based on the principle of what's the word for that? I'm sorry. The word is at the tip of my tongue. I'll be able to recall that later. So based on the principle that the more simple if you can explain hourly wage with less variables, then that's better. Okay, instead of having 100 variables, if you can explain it with only 10 variables, so which is better? Of course, the model with 10 variables that almost is able to explain your dependent variable as well as having 100 variables is a lot better. Okay, so there's a measure called adjusted R squared, and adjusted R squared penalizes your model for adding more. Okay, so your adjusted R squared will always be lower than your multiple R squared. Okay, so the formula for adjusted R squared, I'm not sure if I gave this to you. Did I give this to you, class? Yes or no, please? Did I give that to you? Yes or no? The adjusted R squared formula? Not yet. Okay, let me just share this with you. Control C. Okay, in the chat box, please. Adjusted R squared. That's the formula for adjusted R squared. And it's in LaTeX anyway, so adjusted R squared is equal to 1 minus the quantity 1 minus your multiple R squared times n minus 1 over n minus k minus 1. So this is the formula for adjusted R squared. And the adjusted R squared will always be less than your multiple R squared. So you know n is the number of observations. R squared, we know this already, that's our SSR, right? Okay, so let's compute for our adjusted R squared. Control Alt I. So let's see, AD R square ADJ. Okay, let's just call it R square ADJ, Alt minus. Okay, it's equal to 1. So let's start first with this one. Okay, so it's equal to quantity 1 minus R squared class is our SSR, right? Multiply that by n minus 1, so that's the number of rows, n row, number of rows of wage, okay, minus 1, okay, and then divided by n row, n minus k minus 1, right? N row of wage, okay, and then k is n column of wage, and we have to subtract 1 there because the number of columns of wage includes your dependent variable. K only pertains to your predictors, and then another minus 1 class for the degree of freedom lost for including wage. So this is okay, this is close, right? And then let's close this with a bracket. Okay, of course you can use a parenthesis, and then 1 minus. So 1 minus everything. Open, 1, 2. So there's something wrong daw. Ano yung mali natin? End row minus end column of wage minus 1 minus 1. What's wrong? Ayaw niya ng brackets? Wait. Let me check. Dapat pwede yun. Yan. Ayaw niya ng brackets. Maybe for special use lang. Okay, so 1 minus r squared n minus 1 times n minus 1. Okay, everything in parentheses divided by this whole expression n minus k minus 1, and then 1 minus, let's see, forgot to r squared adj. Run. One minus, hindi, may mali ako. 1 minus 1 minus r squared. Yeah, that's your sum of. Sorry, class. My mistake. Okay. Not r squared is rsq. Why did I use r? Wrong, class, wrong. Sorry. That's not SSR, class. R squared. There you go. Okay. R squared. RSQ. Okay, if I run this, okay na to. 35.94. 35. How much is this? 35.94, 36.31. So medyo may medyo may konting discrepancy. Okay? Maybe they have the formula wrong. R squared. Yeah, this is R squared. N minus 1. Okay. N K is number of predictors, number of columns of wage minus 1 minus 1. And this is correct. 35.94. So may konting tayo, no? May konting discrepancy. Okay? I don't know why. Dapat medyo, it should not be that far away. Okay, anyway, class, we will not at this moment really check kung bakit 35.94 to, but this is the formula for adjusted r squared. 1 minus the quantity 1 minus r squared times n minus 1 divided by n minus k minus 1. So I think I have the correct, the correct. Okay, all right. So what did you get, class? Did you get also 35.94, or were you closer to 36.31? I'm just not sure, class, why I'm getting 35.94. I usually get a figure very close to this one. How about you? May I have your confirmation, class? What are you getting? What's your adjusted R squared? Sure. 35.94 ako eh. So it's a bit off sa 36.3, ano? In your case, class, what did you get? Waiting for your response, class. Hello? Uh, Wait, class. Wait. Uh, what are you missing, class? Did I give already SSR, class? Yung formula? I might be going too fast. This one, class, have I given this to you? Feedback, please, class.
Sir,
Yes.
for this class po, I don't think nabigay na po siya.
How about the others? Nakuha niyo ba itong SSR? Feedback, please. Kasi, sorry, I might be going too fast. And I think I forgot to give you the SSR. Class, hello? Feedback, please.
Sir, yung naalala ko po, yung last lesson, dun, yung last meeting, sir. I think nag-end po tayo dun sa yung unrestricted model.
Yeah,
Tapos, sabi mo niyo po, try namin i-navigate
yeah, lahat,
yung
di ba? Oo.
yes po, yung sa NumDepth, sir. Tapos,
Mm,
hindi ko po sure kung SSR nabigay na. Kasi nag-overlap na po kasi yung nasa utak ko sa Finlit. So,
mm.
yun po.
Say, how about the others, please, feedback? Uh, yung iba naman, paki-feedback naman, please. Hello? Okay. So let me give first what did I give you? SST kanina? Let me give
Sir,
SSR.
yung na ano niyo po kanina is yung adjusted R square.
Hindi, SST, di ba binigay ko kanina?
Ah,
Sa chat
yung,
box?
ay wala pa po sir. Wala pa po sa chat box.
Wala pa? Okay.
Opo.
Sige, let's start with oh, class, sabihan niyo ako kasi nakakalimutan ko na I think sasabihin ko sana kanina na ibibigay ko to, no? Pero wala namang nagbabanggit, class. Please call my attention. That's the formula for SST. Let's start with that, class. Sige. Uh, pero I think I asked you if you got 7160.414. So let's start with SST. Okay? And then let me give na rin yung formula nito. It's a chat box. Okay. Let's start first with SST, class. And then tell me if you got 7160.414. I need your feedback, please. Feedback if you got 7160.414. So SSR class. So you're getting the difference between your predicted value and your mean. And then we square that, and then we get the sum. We should be getting 2752.336. Okay, once again, feedback please for your SSR. Waiting for your feedback class. Hello class, feedback. Okay, thank you. Thank you, Aika. Okay, Julian, thank you. Adrian, thank you. Gab, thank you. Let's give a few more seconds to your classmates. Zeph, thank you. Mababa yung response rate natin. Only 6 out of. Tapos kanina 27 tayo eh. Ngayon wala na yun. 4 students already dropped off. Okay, so let's now go to SSE. And once again, if you were able to generate the 4508, kindly please chat. Good, thank you. But seems like I only have 5, 6 students in this class. Because I'm not getting the responses of others. Okay. Okay, thank you. All right. So, and then what we did was to add SSR and SSE, and let's subtract SST here. So in the interest of time, I'll share this with you. Okay, SSR plus SSE minus SST, you should be getting 0 plus. Okay, practically 0 because SST is simply the sum of SSR plus SSE. And then we were able to get R squared, which is just the proportion of SSR and SST. Okay, so 37.04, which checks with the multiple R squared here, 37.0304. Okay, what doesn't check is this one, adjusted R squared, which we showed to be, which I gave you, this one class, no? I gave this to you. And let's just have one more check. 1 minus R squared, okay, times N minus 1. Okay, and divided by N minus K. This is your K. Because K is the number of predictors. We subtract 1 because it includes wage. And then minus 1 to compensate for the intercept that's being computed also. And then 1 minus this whole thing. R squared adjusted, 35.94. May I know, class, what you're getting for our adjusted R squared? 35.94. Thank you, Jerry Lane. How about the others? 35.94. Okay. So I'll check, class, why. Okay, same. All right, thank you. It should not be far from this one, class. 36.31. I'll check on my formula, but I know this is correct. I've done this for several times already, and it's only now that I'm getting it's quite far, 35.94 and then 36.3. That's not close. Okay. All right. So let's leave that for the moment. I just wanted to make sure that you understand where these are coming from. So except for this, we seem to have okay. We seem to be okay already. This one F stat can also be computed, but wait, 1, 2, 3, 4, 5, 6. $36.19, I'm sorry. So it's 36.19, but it's still quite far off. I was comparing it with model number 2. This one, 36.31. So it should be 36.19, okay? But it's still far, 35.9. Okay, so now we just discussed this class, no? 7 degrees of freedom, the F1 and the F2. Okay. R squared, 37.04. Adjusted R squared, we got 35.9 something. This is 36.19. I'll have to check, class. Okay, and we said, class, that we don't stop there. What we do normally is to check your insignificant predictors. And we can do what we call a stepwise regression. For stepwise regression, we remove the variables one at a time. Stepwise na backward. Kasi may stepwise na forward and may stepwise na both forward and backward. So here, since we have the model here, what we did last time was to do stepwise backward. So what will be our leaving leaving variable? Okay, we look at the t values and we choose which is the lowest as far as absolute value of your t value is concerned. And it's raised, right? 0.257. So what we did was to raise ba? T value, raise. Why did I write here gender? This should be race class. Sorry, this should be race. My apologies. Race is your leaving variable. Okay, so in this next model, what we did was to get model number 2, okay, LM. Then we removed race here. So from 7, we have now 6 variables. And once again, we run model number 2. And what do we have? We have now another solution. The multiple R squared, notice it went down. Okay, because initially there were 7 predictors. 7 predictors, but the multiple R squared will go down if we remove variables. However, the adjusted R squared went up 3631. Okay, 3631. And you have degree of freedom 1, you have only 6 predictors. N minus K minus 1, 526 minus K, which is 6, minus 1, we get 519. And notice that there are still insignificant variables here. So we'd like to see whether this solution, model 2, is better than model 1. Okay, this is what we studied last time. We said that the unrestricted model is the one with more predictors, which is model number 1, having 7 predictors. So this is mod 1, right? Mod 1 with 7 predictors. On the other hand, the restricted is model number 2, the one with 6 predictors. And can we check whether which is the better model? Yes, we can check that. We can use the analysis of variance where we compare model 1 and model 2. The null hypothesis here is that the added variable to the unrestricted, which is race, is equal to 0. So we're testing whether race, the variable race, is not needed for the model. Okay, which indicates that the restricted model is the better model. Okay, so if we run this last time, and we saw model 1. Okay, model 1 contains your race. This is your unrestricted. Model number 2 is your restricted without race here. Okay, and then we check at the p-value class. The p-value is 0.79. So this is very high compared to 0.05. So the answer is we fail to reject the null hypothesis. Okay, when the p is low, the null must go. But here the p is greater than 0.05, so we fail to reject the null hypothesis. Meaning, class, we fail to reject this, that the restricted model is better. Okay, so we can, in this test, we're saying that beta race is indeed equal to 0. Okay, so next step, class, I asked you to do the next steps. Again, take a look at the t-value here. And the lowest here is num-depth class. Okay, so what do we do now? We do another leaving variable. Okay, let me just copy this. Control C. I'll copy this below. Okay. So num_dep is our leaving variable, right? Num_dep. So hourly wage, regression, education, experience, tenure, gender, civil status here. So we remove num_dep. Why num_dep? Num_dep has the least absolute value of t here. 1.33, this is 1.58, this is 1.7. So num_dep is the least. So we're going to remove that here. And let's call this model number 3. Summary model number 3. Okay, when we run this, okay, what do we get? Notice that your adjusted R² went down, but your multiple R² also went down. Of course, when we remove variables, the multiple R² will go down. 36.21 versus here it's 36.31. Okay, but what's important is, again, let's do ANOVA. Okay, here we only have one insignificant predictor, experience. And also civil status is significant, but at 10%. No? And let's do ANOVA here. Just copy this. Control C. Control V. And we're testing model number 2 and model number 3. And our null hypothesis here is that beta of number of dependents, okay, because that's what we removed. So we would like to know if the restricted model, which is model number 3, in this case, is better. Okay, so let's run ANOVA now. Okay, p-value is 0.184. Therefore, okay, we fail to reject the null hypothesis that the restricted model is better. So statistically cast, we can say that number of dependents variable is 0. It has no effect on hourly wage. Therefore, we're going to maintain model number 3. It's better than model number 2. Take note, model 1 and model 2 is not the same as model 1 or 2 in our case. Here, model number 1 has number of dependents. Okay. And model number 2 does not have number of dependents. And the p-value, as I mentioned a while ago, is 0.184 greater than 0.05. Therefore, we fail to reject the null hypothesis that model number 3 is better. Okay, and as usual, okay, and the next step is, once again, go to our leaving variable. It's 1.558, so it's experience. We remove experience. Okay, Control V. So this is expert. Model 4, then model 4. Okay, so tanggalin natin sa experience dito. No? So education, experience, civil status, 4 na lang class. From 7, naging 4 na lang kasi we removed the 3 variables already. So model number 4. Then run natin. Okay. So you can now see that all the predictors are significant. Okay. Initially, civil status was not significant. No? Initially, tatlo lang, education, tenure, and gender. Now, when we remove the others, civil status became significant. Okay. Multiple R², went down 36.52. Adjusted R squared also went down 36.04. Okay, let me pause for a while and allow you to follow up or catch up, class. See, I'll give you a few seconds. And once you're done, class, once we have reached model number 4, okay, then please chat or please tell me if you have any questions. Let me remove the outputs so that you can see the codes. Okay, thank you. So for some of you are able to follow. Okay, good. Okay, good. Thank you. Okay, thank you everyone for the feedback. Okay, and I think we have to check in last class. This one, Control C, Control V. Let's check if model number 4 is preferred over model number 3. It doesn't matter, class, if you put 4 or 3 first, or 3 or 4. It doesn't matter. If you run this, okay. So what do we have, class, here? Again, the null hypothesis here is that the restricted model is better. Okay, here it should be, what was the last one that we removed? Expert, I think. Was it experience? Yeah, experience. Thank you. Okay, good. All right. The p-value is again 0.11. It's way greater than 0.05. Therefore, our inference is that we fail to reject the null hypothesis that model number 4, this is model number 4, is better or is preferred over model number 3. The restricted model is preferred, is better than the unrestricted model. Okay, so kindly please chat in the chat box if the concept of stepwise regression is clear to you. Okay, good, thank you. Okay, thank you. Let's wait for your other classmates. Yeah, thank you. Okay, yes, great. So I'm happy that you're able to follow. However, I would that the others also give their feedback, give their comments. Okay, as we're not even reaching 50% of the class response rate. But if you have questions, please feel free to ask them. Okay, now the problem here, class, is that this is quite a lengthy process, no? If you have 20 independent variables, does it mean that you will have to do that one at a time, one by one? Good thing there are packages that do stepwise regression. So let's go there. Okay. Okay, so the question is, what is the final solution? Okay, so let me just share this with you. Okay, that's our question. What is the final solution? Well, for the wage data set, we were able to come up with this solution, right? This one. Where is that? Model number 4, this one. So this is our final solution. All your predictors are significant. So you have hourly wage is equal to equal to negative 2.16 plus 0.53 times education plus 0.15 times tenure plus 1.71 times gender minus 0.68 times civil status. So this tells us that male employees receive $1.71 more than their female counterparts, and single people receive $0.68 less than their married counterparts, both ceteris paribus. Okay. Good thing there are packages that will give us the an automatic stepwise. So here, we're going to use the step function. This is from the mass package, okay? And we're creating a model, an object called step model, okay? And then step mod 1, this is the full model, right? All the predictors. We'd like to check from model 1, direction is both. What does this mean? Direction is both means that stepwise forward or stepwise backward. Okay, so just to give you the distinction, when you say backward, stepwise backward, so you start with the full model, all the predictors, and then you remove one at a time. That's what we did. That's backward. For forward, what you do is you start with nothing and then come up with adding variables one at a time. Okay, that's forward. And both, it's a mixture of backward and forward. So that's what we have here. Okay, so print and stepwise regression both direction. Okay, the object step model plus step mod 1, this is the full model, right? Hourly wage regression, all the predictors. Direction is equal to both, trace is equal to false, and then let's print the step model, this one. And let's run this. Okay. So this is the stepwise regression class using the step function. And there are differences between what we did and what this does. Okay. Here, 1, 2, 3, 4, 5. 5 predictors. It includes experience and civil status. In our case, we have 4, right? 4. It includes civil status and it does not include experience. So what's the difference? Why does this stepwise regression not lead into the same solution? Now, the reason because is there are two types of stepwise. There are 2 methods actually. So you have AIC method and the p-value method. What we did a while ago was to base our stepwise regression on p-value. If the p-value does not satisfy the requirement of 0.05, then we delete that variable. There is another method called the AIC method. Now, the AIC method allows variables to be included in the solution even if they are not significant. What's AIC means Akaike information criterion. Akaike information criterion. And the basis for this method is that for as long as AIC is reduced, becomes lower. Because if your AIC is lower, it means it's a better model because there's less information loss. What this measures is information loss. So the lower the AIC, the better. So it does not take into consideration the p-value. So even if your variable has a p-value that's greater than 0.05, it still includes that. Okay, so that's why in this stepwise regression, you can see that our solution is different from the p-value that we used a while ago. So the question is, what do you use? Should we use the AIC method or the p-value method? Okay, that's an important question. Now, the answer is both. Okay, both. And it depends on what you're trying to find out. So let me share these notes with you. Okay, here. Let's see if this will. Okay, Control C as notes class to further guide you. Too many. I'll remove this. Sample here, Control X. Okay. All right. Let's first discuss this class. Okay, so in multiple linear regression, the question is, what will be our final model? Should we only use significant variables? The answer is a big not necessarily. Okay, if the theory dictates that, for example, experience is a very important predictor of hourly wage, even if it is not significant, you still include that in the model. Okay, so this is what I said, class. Sometimes theory dictates that you keep certain controls, even not significant. Okay, I'll explain what control variables are, class. That's very important to understand. So let's say experience, we're including it here. Okay, even if it's not significant, you include that. Okay. But you have to define that you're using the AIC method, okay, in order to predict your hourly wage. Okay, now stepwise AIC is often preferred for prediction, class. But for inference, some prefer significant based value models. Okay, so you have two types of objective. Are you trying to predict? Is that the objective prediction of the hourly wage? And if that's the case, then you use AIC. So what does that mean? You include variables that are not significant. Okay, but if you're using it for inference, then you use the p-value method. Okay, now you will have a problem if experience is a control variable. What do you mean by control variable? It means that studies have established that experience is related to hourly wage. But it's not only related to hourly wage, it's also related to education. So this is a case where your experience is related both to your dependent variable and your independent variable. And if you remove this, if you remove experience, you'll have what we call an omitted variable bias. Okay, so it's almost time, class. Now I'll just share this with you. So we'll discuss this next time. Yung concept ng omitted variable bias. Saan ba ako where did I end? Okay. Control C. Okay, so in your thesis class, you will hear your panelists or your panelists say, what are your control variables? Okay, so that's very important. Yung understanding ng control variable is important. Okay, it's practically time, class. We'll discuss this, class. next time, because there's another package. There's a package called OLSRR. So we're going to take a look at doing stepwise regression using OLSRR. Okay, we're going to use backward stepwise. We're going to use forward stepwise. We're going to use AIC. Okay, we're going to use the p-value method, and we're going to okay, I'll share this with you now. Okay. Kindly copy that class so that next meeting don't have to there. Okay. And this one also. Okay, so we have next meeting class, we will finish our discussion on stepwise regression, okay? And then we go to ano ba yung next natin? Diagnostics na tayo. Okay, we would like to finish already our topic on multiple linear regression, and then we move on to logistic regression and then time series analysis. Okay, so let me stop recording now.